In this video, we're going to talk about LeChatelier's principle, which states that when a stress is applied to a system at equilibrium, the system will respond to minimize the stress. So if a system is happy chemically and something is done to that system, the system will try to revert back to its original state. There are three main types of stresses that can alter an equilibrium system. The first is concentration. Reactant or product can be added or removed. The second is temperature, so the temperature of the reaction can be increased or decreased. And the third applies only to gases, and it's changing the pressure or volume. And if you remember from Boyle's law, pressure and volume are inversely proportional. So if the pressure is increased, the volume is decreased. If the pressure is decreased, the volume is increased. And that will come into play when we talk about pressure. In LeChatelier's principle, we're going to talk a lot about shifts. So when we say shift right, what we mean is that the system has produced more products in response to the stress. If we say shift left, what we mean is that the system has produced more reactants in response to the stress. And so if we think about a chemical reaction, A and B, A, our reactants are on the left side, so producing more of them would be a shift left. B, our products are on the right side, producing more of that would be a shift right. The first stress we're going to talk about is changing the concentration. If we increase the concentration of a species in our reaction, we're going to increase the number of collisions that species undergoes. If we increase the number of collisions, we're also going to increase the rate of reaction that consumes that species. So if we increase the concentration of a reactant, we're going to increase the number of collisions between reactions. We're going to increase the rate of our forward reaction, which uses up that species. What that's going to do is cause a shift. So it's going to shift away from the added species. So if we add reactant, it will shift right. If we add product, it will shift left. Now, if we were to decrease the concentration of a substance or of a species, we're going to decrease the number of collisions that occur. And that's going to decrease the rate of reaction that consumes that species. And why that's important is now we're going to be producing that species at a faster rate than we can use it up. And so what's going to happen is our reaction is going to shift towards the species that we removed to replace it. The next stress we're going to talk about is temperature change. In order to know temperature change, we have to know if a reaction is endothermic. So energy is a term on the reactant side. Or if our reaction is exothermic, where energy is a term on our product side. In either case, when we have energy as a term in our reaction, that energy is kinetic in nature. So that is excess kinetic energy. That is balanced out by potential energy stored in bonds. So if we increase the temperature of a reaction, what we're really doing is increasing the kinetic energy. And our reaction will shift away from the energy term. So if our reaction is endothermic, we add energy, it's going to shift to the right to use up that added kinetic energy and convert it to potential energy. Now, if we decrease the temperature, what we're doing is removing kinetic energy. The reaction is now going to shift towards the energy term to replace that removed kinetic energy. So if we look at our exothermic reaction, if we were to remove energy from this reaction, the reaction is going to shift right to replace that removed energy by converting the stored potential energy into kinetic energy. And the last stress we'll look at is changing pressure and volume. This only works for gases. So I'm going to use a model equation. So I'm going to do 2A gas molecules in equilibrium with 1B gas molecule. So one thing to note that's really important is the number of the number of moles of gas you have. So we have 2 moles on our reactant side, 1 mole on our product side. 2 moles of gas takes up more space. So if we were to increase the pressure, we're really decreasing the volume. We need then to shift towards the side with fewer moles of gas to take up less space. If we were to decrease the pressure by increasing the volume, we now have more space for our gas, and so we're going to shift towards the side of the reaction with more moles of gas.